Right now, as you're sitting there watching this explainer, you're actually surrounded by an invisible web of data, just raining down from the sky. It's a system that quietly runs the entire modern world, yet it hides a really profound cosmic secret right inside our everyday technology. Today, we're going to pull back the curtain on something you use all the time, but probably don't truly understand. Let's dive right in. So, what's the hidden scientific secret that makes your GPS work? I mean, you probably don't give it a second thought when you type an address into your phone, right? But there is a direct, literal line connecting your everyday commute to the fundamental laws of the universe. What could possibly link, say, ordering a taxi to the deepest mysteries of space? To really grasp this secret, we've got to look at the sheer scale of what we're dealing with. Billions of us use GPS every single day. We use it to find a quick bite to eat or to navigate our cities, but it's so much bigger than that. Pilots rely on it to guide aircraft through the skies, massive cargo ships need it to cross oceans, emergency services depend on it to literally save lives. The entire global economy basically teeters on the reliability of this one single system. And yet, all of these incredibly essential functions are balancing on the edge of a massive scientific illusion. Because here is the shocking truth. Time on Earth and time in space are fundamentally different. I know, it sounds straight out of a science fiction movie, doesn't it? But it's a hard physical reality. According to modern physics, time simply does not pass at the same rate everywhere, which means your GPS isn't just a map system. Actually, it's an incredibly fragile time machine. And if scientists ignored this fact, the technology guiding billions of people would just completely fail. Let's look at part one, the hidden importance of time. You see, the global positioning system is really a network of satellites orbiting the Earth, constantly firing signals down toward the planet. And inside every single one of those satellites is an extremely precise atomic clock. Now, that precision is absolutely vital because of the massive number you're looking at right now, 300,000 kilometers per second. That's the speed of light. The timing signals from those satellites travel down to your smartphone at exactly that speed. Your phone figures out where you are by measuring precisely how long those signals take to arrive from multiple different satellites all at once. But because light moves so incredibly fast, the whole system relies on measuring completely microscopic fractions of a second. And this brings us to a crucial point. A timing error of just 1/1,000,000th of a second shifts your GPS position by hundreds of meters. Just think about that for a second. 1/1,000,000th of a second. A microscopic miscalculation in time completely shatters the reliability of the entire system. If that satellite clock is off by a fraction of a heartbeat, well, you're not on the highway anymore. Your map thinks you're driving through a building 3 blocks away. GPS absolutely requires clocks that stay perfectly synchronized. Which leads us perfectly into part two, Einstein's revolutionary discovery. Keeping those clocks perfectly in sync means dealing with something that completely overturned human understanding. For centuries, we basically thought time was absolute. We figured a second ticking away here on Earth was exactly the same as a second ticking away anywhere else in the universe. But Albert Einstein completely shattered that illusion. He proposed something radical. Time is not fixed. It isn't universal. Time can actually move faster, and it can move slower. The rate at which time passes literally depends on speed and gravity. Back when he first brought this up, people thought these were just weird mathematical quirks. Nobody could have imagined they'd become the backbone of our everyday tech. So let's break down exactly how this works, starting with special relativity. In simple terms, this is the theory that time moves slower for objects traveling at extremely high speeds. Now, GPS satellites are hurtling around the Earth at thousands of kilometers per hour. Because they're moving with such incredible velocity, the atomic clocks on board those satellites literally tick slower compared to a stationary clock sitting right here on Earth. Motion itself actually changes the passage of time. But wait, there's an even stranger truth, and this one comes from Einstein's general relativity. This theory proved that gravity also messes with time. Basically, the weaker the gravity, the faster time passes. Since those GPS satellites are orbiting way up high above the Earth, far from the planet's main bulk of mass, they're in a much weaker gravitational field. And as a direct result of that, their onboard clocks actually run slightly faster than our clocks down here on the ground. It's wild, but gravity actually alters time itself. All right, part 3, the constant battle of time. So, picture this. We've got two completely bizarre physical phenomena happening at the exact same moment, thousands of miles above our heads. On the left side, special relativity is trying to slow the satellites' clocks down because they're moving so fast. But on the right side, general relativity is actively speeding those same clocks up because the gravity is weaker. It's a constant, invisible cosmic tug of war happening inside the satellite. But here's the kicker: they don't cancel each other out perfectly. The gravity effect actually wins out.
The net result of this whole cosmic battle is exactly 38 microseconds. Every single day, the clocks on those GPS satellites gained 38 microseconds compared to the clocks in our pockets. Now, sure, that might sound like absolutely nothing to you and me, but remember how fast light travels. In a system built on extreme precision, that tiny little daily drift is a catastrophic problem if we don't fix it.
Let's look at the cascading failure that would happen if we just pretended Einstein's math wasn't real. In the very first hour, the clocks would slowly start to drift. By hour 24, those navigation errors would grow pretty huge. By day 2, your location would be off by several kilometers. Drivers would get completely lost. Aircraft navigation would become incredibly dangerous. Global shipping routes would just fail. By day 3, the entire modern infrastructure would experience crippling disruptions. So relativity isn't just some abstract theory. It's a strict, practical necessity for the modern world. So how do engineers keep everything from falling apart? Through a massive practical engineering triumph. Scientists literally bend the rules of space-time to keep your car on the road. First, they calculate all those relativistic effects. Second, they actually adjust the satellite clocks so they run slightly slower before they're even launched into space, compensating ahead of time. Third, ground stations are continuously monitoring them. And fourth, they apply highly complex mathematical corrections to every single calculation. They literally treat relativity as everyday engineering. And that brings us to part 4, the big realization. All of this mind-blowing science, this literal manipulation of space-time, brings us to the point where cosmic physics directly intersects with your daily life. You know, a lot of scientific theories only ever get tested in isolated underground labs, but GPS is different. It's running constantly all over the planet. Every single time you open a navigation app, every successful route you drive is real-world confirmation of Einstein's predictions. The exact same tech you use to find a local coffee shop is, in reality, a continuously running, planet-wide proof of relativity. If Einstein was wrong, your GPS simply wouldn't work.
Honestly, it's a beautiful, almost poetic irony. Think about it. Einstein never built GPS. He never used a smartphone. He literally never opened a navigation app in his life. His life's work was driven purely by scientific curiosity about the fundamental fabric of the universe. Yet, his incredible discoveries about space, time, motion, and gravity ended up becoming the invisible, essential backbone of modern human existence.
The universe operates in ways our human brains just aren't wired to intuitively understand. Time literally changes depending on motion and gravity, and that little device in your pocket depends entirely on principles that once seemed absolutely impossible. So I'll leave you with this. Next time you open your map app, will you remember the hidden cosmic physics guiding you? Will you look at your everyday device with a completely new sense of profound wonder? Think about that the next time you're asking for directions. Thanks for joining me on this explainer.